Thanks everybody for coming. Today I will present to you my project, my bachelor thesis I will present to you how I set up a pipeline to translate Egyptian hieroglyphs from an image. First, a bit about myself. My name is Susi Gentsch, and I'm currently finishing up my bachelor degree at the University of Bonn, studying computer science with a focus on computer vision. The project that I'm presenting today to you is done in cooperation with Bonn Trainee, a program of my school where students and AI experts come together with subject matter experts to find solutions for their problems. Here's a quick overview about about HieroGlyph2Text. At first, the user inputs an image with a prompt. With object detection, the pipeline then cuts out the single hieroglyphs and passes them into the classification model, which returns Gardiner Codes. These Gardiner Codes are then translated with a language model using RAG, and out comes an attempted English translation. I want to give you a quick overview about what I'm talking today. At first, I cut down the problem. Then I will present to you the data sets that I used to train the models, followed by going in depth about the hieroglyph detection, the classification that I have done with PyTorch, and the translation that's done using RAG with Llama 3.1. In the end, I will give you a quick demonstration about how it works. First, when we want to translate hieroglyphs from an image, this problem can be cut down into 3 subproblems. First, the detection of the hieroglyphs, then their classification, followed by the translation. Since you can't write hieroglyphs with your keyboard, Egyptologists use Gardiner Codes as a lookup table for them. As we all learned in elementary school, I'm sure, we know that this small image of a bird is called G17. A few challenges when it comes to dealing with hieroglyphs are, first of all, there are a lot of them, hundreds of them. And when we see them in the field, they're often not perfect. They're malformed or in irregular grouping. And when it comes to the translation, the same group of hieroglyphs doesn't always mean the same thing, have the same translation. The translation often depends on the broader context of where the hieroglyphs appear. The data sets that I used for my model training are, first of all, the Frank Morris data set for the image detection and classification. This is a data set with 10 images of the walls of the pyramids of Unas. Along with them are about 4,000 annotated images of individual hieroglyphs, along 162 classes of different Gardiner Codes. For the language part, I created a custom RAG dataset that contains about 1,000 lines, entries, saved in a JSON lines format, and each entry contains a unique Gardiner Code, its description, and/or ideogram. This is what this dataset of the small images look like, and here are a few example lines of the RAG dataset. Now to the object detection. For the object detection, I decided to go with YOLO V8 because it performs very well at detecting small objects on large images. I trained it to detect various types of hieroglyphs in an image. The data set I used for that, I split 70% into training, 20% to validation, and 10% for test. Now to the classification part. I designed my classification model with PyTorch. The key points why I used PyTorch for this was, first of all, PyTorch has a rich ecosystem of pre-trained models like ResNet and libraries that help to work with it. Then secondly, its dynamic computational graph was very helpful to adapt ResNet to my specific needs. The PyTorch data loader, further, made it very easy to load and shuffle the data around during the training. Another benefit of PyTorch was the seamless GPU integration. When the object detection returns the cut-out images of hieroglyphs, they're not in a perfect square shape, what ResNet needs to work with them. So at first I standardized the image size, and then I increased my data set by doing some standard augmentations with torch-vision.transform. The final classification model that I ended up using was the result of extensive experimentation with different architectures and configurations of ResNet. The best performing model was a customized version of ResNet 50, in which the key modifications that I applied were first that I changed the input layer to only accept grayscale images, and secondly, I changed the final layer to be adjusted for the custom amount of classes of Gardiner Codes appearing in the dataset. I split the data for the training 70% for training, 15% for validation, and 15% for test. The accuracy on the test data ended up being 94%, which exceeds previously published results. Now to the final part of my pipeline, the translation. When I started with this part of the project, Llama 3 just came out and it was not able to translate Gardiner Codes. This is why I had to teach it what Gardiner Codes meant. I tried to put this in a prompt input, but the context window of Llama 3.3 was too small at the time. This is why I created my RAG. My RAG can be cut down into 4 key parts. First, the indexing, the retrieval, augmentation, and generation. For the indexing, I created embeddings of the RAG dataset with Llama 3.1. These I saved in a local Chroma DB vector database. Once I have the database, I can use it. The Gardiner codes from the image models are being passed to the retrieval, which generates embeddings for each Gardiner code and retrieves the matching information in the Chroma DB database. The retrieved data is being saved in a dictionary containing the Gardiner code, description, and ideogram. This information is then being passed to the augmentation stage, where I constructed a detailed prompt containing the received dictionary and a detailed translation instruction that tells the model to emphasize on the meaning of the hieroglyphs rather than linguistic accuracy. This prompt is then being passed into Llama 3.1 and it returns a translation. Here's an example of an image of the pyramids of Unas. I passed it into my HieroGlyph2Text pipeline, and I had the first 20 hieroglyphs being translated. At first, the HieroGlyph2Text returns each Gardiner code with their description, with their meaning, and then it tries to form sentences with all Gardiner codes combined. To put it all together, I created an image-to-text pipeline to translate Egyptian hieroglyphs. This combines computer vision with large language models. In the end, I used YOLO V8 for the hieroglyph detection and a customized ResNet model for the classification. The translation then happens with Llama 3.1 using my RAG system. This brings an interpretive translation of hieroglyphic imagery. This project lays the groundwork for Egyptologists to share their knowledge, and with the ease of talking to a large language model, and with their knowledge, we can achieve automated, real, legitimate translation of Egyptian hieroglyphs. I appreciate your interest in this topic, and I'm open to questions. Thank you.